So today I'm going to explain you the new log, which is a basic IMS call received by the device. It's an incoming IMS call we have received, but we have not answered. So let's analyze this log. So this is the log file, IMS call not answered. This I have opened it in QCAT as usual. Go to the filters. You uncheck the all logs option and check only the signaling and say OK. And after that, you make sure that you have enabled QMI messages. QMI messages are useful to understand what requests that modem has received and what is the result. So these requests are nothing but the events that are happening at the GUI level. So whatever events that user is doing in the GUI, they will be sent as a request to the modem. Modem will execute it and then respond back. So this is the option you need to check always. So first of all, we need to check in which mode the device is. So for this, you can always check this kind of QMI message, means get system selection preference. So which will give you an idea on which mode the device is currently operated. Is it in triple mode, GSM, UMTS, or only 2G, 3G mode, or only 2G mode? So what kind of setting user has made in GUI? So that will give you an idea what kind of registration that the device is going to perform. So this one, if you search, always make sure we are doing a regular expression and list all occurrences. So this is the result. If you go there, this is an indication. That means modem has indicated to the real telephony that currently the modem is in this particular mode, GSM, UMTS, LTE and TDS, CDMA. So that means it is capable of registering on LTE network as well. So we are in this mode. And one more thing, this is an indication given by modem. So before started collecting the logs itself, the request has already been given to the modem asking to operate in this particular mode. So that log is not captured. But these are the periodic indications given back to the real telephony by the modem, which will indicate currently what is the modem preference. So we are in this. Here if you see, the device started scanning WCDMA cells, EMTS cells. So then our question is why it is not trying for LTE first. The reason could be at that moment there is no LTE cell available. So it started with whatever cell that is available. Eventually it is a WCDMA cell. So we started reading the system information. We came down, we read the system information and then started registration on the LTE WCDMA network. See here, we are sending RRC connection request in UMTS. So this is the 40449 Airtel Telangana network. So if you see the establishment cause registration, that means we are registering on the WCDMA network. So we send RRC connection request. We got RRC connection setup from the BTS. UE configured its layer 2 based on the RRC connection setup information and responded back with RRC connection setup complete. So this is the connection procedure which is completed. That means connection is established successfully. Now, sending RRC connection setup complete, we are sending location update request. In this, so that means we are registering on a WCDMA network. We send location update request. So authentication procedure started, authentication response is in security mode in WCDMA, security mode complete. Here we are seeing one abrupt signaling connection release. So this is suspicious. Ideally, once the authentication procedure is done, security mode procedure is done, then we need to wait for the command or location update accept from the network. But here we are seeing signaling connection release that is initiated by mobile handset. This is MS to BS. So it indicates the signaling connection has been initiated by the mobile handset. So this is unexpected. Why it is sending RRC connection release without completing location area update? So there must be some event would have happened by the user. So if you track back, here I am seeing one request from real telephony. This is the request that modem has received, which is indicating there is a change in the DDS sub, default data subscription. There is a change. So whenever user changes the default data subscription, the device has to update to the network that its capability got changed. So to indicate that, it has to do either attach procedure or a tracking area update or location area update again freshly, because in the UE capability it will indicate this change to the network. So for that purpose, it immediately terminated the existing procedure which is currently going on and then started RRC connection release. So RRC connection release request has been sent to the base stations. Base station has triggered the RRC connection release and UE completed the RRC connection release procedure. So after this, then again UE has to do freshly initiate a attach procedure. So at this moment, because it is freshly doing a cell scan, now it is able to find the LTE cell. That's why it started acquiring the LTE system information. So here it acquired the system information and then see 40449 Airtel LTE network. We read the system information and then triggered attach request. NAS has triggered attach request. If you see the attach request, we are seeing combined EPS IMSI attach, which indicates UE wanted to register both in the LTE network as well as in the legacy network. Hence, we have set this attach type as combined attach. So, in order to send the attach request, first of all, we need to establish a RRC connection. So, RRC, LTE RRC of the device has initiated RRC connection request. And see the signaling cause. The signaling cause is mobile originating signaling. So we send RRC connection request, and before this, we should see LTE RACH procedure. So for that, always make sure that you are checking these 4 messages which are related to LTE random access procedure. So if I set it, then you will see once the RRC connection has been triggered to the lower layers, the lower layers started acquiring a cell. This is the random access procedure. So random access request, random access response, and then message 3 and message 4. Message 4 will indicate the result, whether the random access is successful or not. Here you are seeing it is successful, pass. So once the random access is done, that means you have a connection with you are in sync with the network. Now you are ready to send a RRC connection setup. We have received RRC connection setup from the network. So this RRC connection setup being the first message from the network, initially it must establish a signaling radio barriers. So it is adding one signaling radio barrier. If you see in the to add modify list, SRB. SRB indicates signaling radio barrier. So signaling radio barrier identity is 1, SRB1 has been added by the network. So we have received RRC connection setup. UE configured its lower layers and responded back saying RRC connection setup complete. Then once it is sent, it has to wait for the network command. So next network is asking identity request. Identity request type is 3, which will indicate the temporary identification of the UE. So UE had sent identity response with its temporary identity that is stored in the SIM card. So identity request, identity response, then we'll have ESM information exchange will happen. So in this, it is indicating what is the access point name that the UE wants to access. So this is the access point name, Airtel GPRS. This is the PDN name of the Airtel LTE IMS network, which you can see in your device settings as well. This is configured by the network. So we have given the access point name to the network, indicating that we want to connect to Airtel GPRS. So this is the RRC level security command, security mode command, security mode complete. Then there is an exchange of UE capability. Network is asking UE's capability with respect to UTRON, EUTRON and GRAN. So with respect to all these 3 domains, what is your capability? So UE has to respond back for all these information about all these RATs. So it will include in the response message. UE capability, if you see, it will include RAT-wise its capability, whether what all features it is supporting, what all RATs it is supporting, it's operating in duplex, full duplex, or half duplex. So you can see all 3 RATs information. So UE capability we have given. Now the network is doing RRC connection reconfiguration. Reconfiguration means any changes to the existing connection will be indicated by RRC connection reconfiguration. So changes can be adding a measurement object to indicate what all cells the UV has to measure and respond by. Or it can be related to your signaling radio bearer, or it can be related to adding a new data radio bearer. So all these kind of changes will be indicated to the UE in RRC connection reconfiguration, and accordingly UE configures its lower layers and then respond back with RRC connection reconfiguration complete. So in this UE is asking, UE was asked to do some measurements with respect to cell selection. So it is adding a set of cells, it is indicating a set of cells to the UE, which it has to measure and report back periodically. That is the purpose of this RRC connection reconfiguration message. So we have done that, then we have received attach and accept from the network. So if you see the attach and accept, the attach result indicates whether the attach is successful for both UMTS and LTE networks or only on LTE network, or it's completely failed. So if you see the result, it indicating combined EPS IMSI attach. So this is successful. That means you are now registered on LTE as well as UMTS networks. We have got a GOTI also. We have got IPv6 and IPv4 addresses. That means your PDN connection is also successful. Once the PDN connection is successful, you will have an IP address allocated to the handset device. So here you could see that one IP address has been allocated. As explained earlier, during the attach request itself, we will always include a PDN connection to the internet as well. That is the main property of LTE. The reason is LTE always guarantees a data connection. It is always connected. So if you see the LTE attach request, in the ESM message container part, you can see a PDN connectivity request, which has been sent by the UE to the network. So this message is nothing but you are asking the LTE network to connect the device, allocate an IP address, make it available always. So accordingly, network has allocated an IP address to the device and made it active in the EPC, in the core network. So active means you have the UE context available in all the core network nodes. So your attach is successful here. Next, it has to activate the default bearer for the PDN, internet PDN. So accordingly, we have received a PDN connection request from the network. So here we are seeing Airtel GPRS. So it has given us one default bearer with radio bearer identification, and see EPS bearer ID is 5. So it has given EPS bearer ID 5, which is a default radio bearer for the internet PDN. So this will always happen whether you activate a VoLTE service or not. This internet connection is always available as soon as you enable your LTE capability in the device. So this is the active default EPS bearer context response message we are sending. Then we have got attach complete. We sent attach complete to the network, indicating that we have successfully configured our lower layers with whatever configuration for radio bearers and signaling bearers, whatever is indicated by the network, we have configured. Hence, we are sending a complete message. You can attach complete. So if you see this, again, there is one more RRC connection reconfiguration complete message. So here you see one more RRC connection reconfiguration message. As I indicated earlier, there will be multiple RRC connection reconfigurations because based on the changes in the configuration, every time there will be RRC connection reconfiguration to the device. So here one more set of RRC connection reconfiguration request and response. So at this point, by this time, you are now registered in the LTE network. So the next part pending is registering on IMS network. So because the device is IMS capable, so we have UE has triggered a PDN connection request. If you see, it is initiated by the mobile handset to the base station. It is a PDN connectivity request message. This PDN connectivity request is for what? This is for the IMS network. Earlier PDN connection is for the Airtel LTE network. This is for IMS network, Airtel IMS network. So we send PDN connectivity request. So again, we have got RRC connection reconfiguration. In this, you will have a data radio bearer established, EPS bearer identity 6. Because to send this PDN connectivity request, first of all, the device requires a dedicated data connection. So far, whatever has been done in attached procedure is a LTE default bearer establishment only. There is no dedicated bearer established allocated by the network. So now, because we are asking a PDN connectivity request to be sent to the network, there must be one RRC connection reconfiguration which has to include the dedicated bearer to the UE. So this is the dedicated bearer, which is ID 6. And corresponding lower layer parameters. So we have now network is asking to activate a default bearer for the IMS. See IMS. If you see RRC, activate default EPS bearer context request that is received by the mobile handset is having an indication that it is for IMS network. So we are establishing IMS access point name. And we have given a default EPS bearer context and accept EPS bearer ID 6. So we established the EPS bearer for the IMS network. So once the default bearer PDN connection to the IMS is also done, the next step is our IMS module will send registration for the IMS. So we are seeing IMS SIP registration request from mobile handset to the network. Then we will see IMS SIP register unauthorized. Then we have to give IMS SIP informal response. Then IMS SIP registration OK received from the network by the device. Here you are successfully registered in the IMS network. If you see, this IMS register OK has been received, which is having the MCC MNC numbers, which will give you the network ID on what network you have registered. 40445 is the network ID of Airtel. So IMS SIP registration is successful here. Then let's see what happened in the log. So now we are registered successfully in LTE network on GSM UMTS networks in the form of combined attach, and then we have successfully completed IMS registration. So we must be able to make VoLTE calls on the LTE network, IMS network. So there is now he is in idle mode. He is in idle mode, waiting for some event to happen. So here user has triggered, dialed one number. That number is 9000242723. So this is a request received from real telephony to the modem. So we have received a request from real telephony, that is indirectly by the user, asking us to connect to this number. He dialed this number, so call type is voice. So he wants to make IMS call. So this message is important, which will give you what kind of call we are establishing. This is a call to this number, and the voice type, call type is voice. It means voice over LTE. Then we have service type automatic. So here the service type automatic indicates if in case IMS voice call is failed, it means you are not able to make a VoLTE call. Then the device has to fall back automatically to UMTS and try to establish a CSFB call. If this indicates only IMS, not automatic, then what happens is if in case the IMS call fails, then it will not fall back to CSFB. It will simply send a failure message to real telephone saying that due to some network issue, it is not able to establish a voice call on the IMS. But the configuration, if the device is configured to have an automatic type, then the modem will by default fall back to CSFB if IMS call fails. So here the type is automatic, so there is no problem. If IMS is not successful, then we will try on UMTS. So this is the first message that the device is sending to the network IMS core, asking to establish a call. In this we will see the call has been originated by this number 8197419515. The call is to 9000242723. So this is the invite message. So invite message has been received by the core and has been indicated to the other party, saying that you have an incoming call. So that other party device has responded back. That's why the network is giving us trying. It is giving a response saying trying. That means at the called party side, the process has been initiated to establish the voice call. That means the other user already been alerted saying that there is an incoming call for you. So if you see the called party logs, then you will see what kind of indications network has given to the called party to make the call. So we have got a response from the network saying the call has been alerted. Then session is in progress. Ideally, once the trying comes, the device next message that we receive is session progress. So we have received one more message from the network saying that session is in progress. Now, once the session is in progress, now it is time for the network to have a dedicated bearer, because for the voice call, we need a guaranteed quality of service. So we need a specific throughput to make a voice call on a IP network. Because LTE is a IP network, we need dedicated data bandwidth to make a voice call. Otherwise, call will not be clear. It will be broken. So to achieve the desired quality of the voice, we need a dedicated connection. Hence, the network initiated a dedicated data bearer establishment. See, it is given an indication activate dedicated EPS bearer. Here we are seeing one parameter called linked EPS bearer. This linked EPS bearer indicates what is the default bearer that is associated with this dedicated bearer. So this ID6, earlier I explained you, this ID6 is associated with default bearer for IMS. Now we are linking this dedicated bearer with this default bearer. And the new dedicated bearer ID is 7. So 6 indicates what is the default bearer that is associated. 7 indicates what is the new ID we are giving to this dedicated bearer. So we have received a new dedicated bearer 7 associated with default bearer 6. Accordingly, we configured our device and responded back to the network saying that your EPS bearer has been configured successfully in the device. So accordingly, we are sending a track. This is called positive acknowledgement. We are giving a positive acknowledgement to the network. This is IMS message indicating that we are ready for the call. Whatever configuration that you have indicated, we have configured our device and we are ready. So this track message indicates that from handset side, the configuration is successful. Sometimes the configuration can fail here. So in that case, it's a failure. We are not able to make IMS call. But in this case, in whatever log that you are seeing, it is a successful case. So IMS track network also acknowledged our message. Then IMS, there is one more modify EPS bearer context. See, these modifications can come based on the negotiations that are happening at the IMS level. So RRC accordingly modifies RRC connection. Maybe if there is a change in QoS or something, or some algorithm, change in some algorithm, then it will modify the EPS bearer. Then we have received IMS ringing. So this is from the base station to our device. So that means other party user has been ringed. So the ring is going on. If the user picks, then we will answer the call. Otherwise, if the user doesn't pick the call, then it will ring for predefined time, maybe some 5 seconds or 10 seconds, and then call will be disconnected automatically. In this case, now at this stage, the other party user is getting a ring indication in his device. So the ring is going on. Yeah, so there is no response from the called user. Here you see MS to BS. That means we are cancelling this call because user did not respond for predefined time. So we are cancelling this call. Hence we are sending this call cancel to the network, and network has acknowledged saying that I have released the resources which are established for this call because user did not respond. So it is giving cancel OK. Call has been cancelled. We made the SIP invite invalid. We have got the acknowledgement also. Once the IMS call has been cleared, then we need to release the bearers, whatever we have established. So deactivate EPS bearer, whatever dedicated bearer that we have established, we are deactivating it. If you see the dedicated bearer ID 7, which indicates the dedicated bearer that we had established earlier for this call. Now we are clearing it. So we have dedicated bearer has been cleared here. That's it. The log is ended. This is an end. Here, now we have a question like why this call has been cancelled. What is the event to trigger this cancel message? So if you track back, you will see one message request from the real telephony saying that voice call end. It is a request. So it is user is asking to end the voice call because the other party is not responding, with end causes user reject. So because the modem has received this QMI indication, this IMS has initiated this cancel procedure. So this event, this cancel call event, can be triggered in two ways. Either user can manually disconnect the call by pressing on the red button, or there is a timer, 5 seconds timer. So during this 5 seconds, if the other party did not respond, then we automatically disconnect the call. So this indication at this stage, we will not be knowing whether it's a timer based trigger or user initiated trigger, but the trigger is end the call. So if you see real telephony logs, then you will come to know whether user has disconnected the call or timer expired and call got disconnected. So this is the complete log. So if you see whatever filters I had set, so these are the required filters to understand this IMS registration, LTE registration, and voice call establishment. So I filtered out all other messages. I kept only whatever bookmarks I have made during the log analysis. So these bookmarks, if you set it in any text analyzer tool, whatever I explained you, if you set these in text analyzer tool filters, you can see in text analysis tool also this entire log. So these are the important bookmarks we have to use for studying this IMS registration, LTE registration, and then IMS call. So you save these filters one by one. Take the keywords. If you save this NAS get system selection preference in a different text file, IMS LTE and IMS call filters. It will be useful for you to analyze the logs. So this get system information will give currently the device is in which mode. Is it in 2G, 3G LTE mode, or only 2G mode or 3G mode, something like that. So here mode preference will tell you we are in which mode. In our device, we are currently in triple mode, including CDMA also. So we have this, you can save this also. join them with a pipe symbol. All these filters without any space. Then we have RRC connection request. So to have all these RRC messages, you can have WCDMA signaling messages as filter string. Then we have NAS messages, UMTS NAS. You can say UMTS UE OTA. OTA indicates over the air. So which will give you all UMTS over the air messages. All NAS messages it will give. So then you can have the security mode command complete. This is one more indication. This is the standby DDS sub. This is one more important parameter. DDS means default data subscription. If you have two SIM cards in your device, then you will have one SIM card as a default data. So that you can see in your device user interface, there is an option in settings to choose your SIM card, which needs to be a default data subscription. So if you, whenever you change this setting, for example, if initially it is SIM1 is your default data subscription, and then later on if you change it to SIM2, then the device will detach from the network and do a reattach. That is because it has to indicate to the network that its preferences got changed, device configuration got changed. So this needs to be registered in the network. For that purpose, it will initiate an attach procedure or sometimes a tracking area update procedure. Usually when the default data sub got changed, Qualcomm implementation is to trigger an attach instead of a tracking area update. The reason is tracking area update usually can have some failures, but attach is the highest priority, so we'll have less number of failures. So we usually, when DDS sub got changed, then we usually trigger attach procedure instead of a tracking area update procedure. So we are sending attach. You save this filter LTE NAS, this DDS notification also. This is a request from the real telephone. That means user has changed the reference. And later on, we are triggering attach procedure because there is a change in the default data subscription. If you choose this NAS LTE EMM, NAS plain water, then it will give you all LTE outgoing messages of NAS. You can have session management also. Activate default EPS bearer is a session management message. So we are saving this also. Activate default EPS bearer, attach complete. Then there is one more PDN connection request. This is for IMS. So in order to register on IMS network, first we need to establish a PDN connection with the IMS entity. PDN connection establishment is nothing but you need to have a IP address allocated from the IMS network. So now you will have two IP addresses, one from the internet PDN and the from the IMS PDN. So internet PDN IP address is already available for you in the attach complete message, attach and accept message. In this you will see the IP address allocated by the internet PDN. Here this PDN connection will facilitate to have another IP address from the IMS network. So we got PDN connection request, EPS activate default EPS bearer. Any PDN connection, any new PDN connection requires a default bearer. If you are connecting to internet PDN, you need one default bearer, which we have already established during attached procedure. This is a new PDN, which is IMS. This also requires a default bearer. So we got a default bearer establishment request from the network. This protocol container will have the IP address allocated for the PDN connection. See here network is telling I allow only IPv6. So accordingly we will have IPv6 address. Once the PDN is established, then we will have the IMS signaling starts. So these are the IMS signaling messages which I have already explained. So if you put this filter IMS SIP message in your text analysis tool, then you will have IMS messages appearing in your text analysis tool. So we have IMS registration, and then we have IMS call. SIP invite will tell you what kind of service you are seeking. See here it is telling call ID. SIP invite, call, to and from messages we will have, and it will give the properties, SDP protocol related information, all other information that are required for the IMS call. So these filters, if you have in your whatever filters I have put it in this text file, you save them always. Whenever you analyze a new log, you add new filters. You increase your filter database, which is very useful for you to analyze new set of logs easily. This is call related indicator. So the log analysis is done. So you go through this video, open the same log file, try to analyze it in the QCAT as well as text analyzer tool, and try to understand each and every message, whatever I have bookmarked. These are all important messages. And